everybody. Welcome to your review video. I know you guys have been patiently waiting for this video. And basically I'm just going to go over the first review, and I'm going over all of it, not just the evens. And then I'm probably going to go over the questions from the game today. So, because the questions from the game really outline what you'll be doing on the test today. Tomorrow. So, welcome to the 3C review. So, please look out for 2 videos, not just one. There'll be this video, and then the second one will be the questions from the game. Alright, let us get started. Alright, number 1, we did this question in class, and basically you need 3 things to be able to graph this. You need your local max, you need your local min, you need your x-intercepts, and that pretty much is everything that you will need to graph this. Okay, so I'm just going to put it into my calculator. Make sure if you can't see your graph, you put it on Zoom 6. Alright, I noticed that I hit the graph in 4 places. I hit it at -2, since that is an intercept, at 0, at 1, and 3. Those are my 1, 2, 3, 4 real solutions. So I'm just going to skip down here, and where it says number of real solutions, I'm going to put 4. Since the degree is 4, I should have 4 total solutions. So 4 minus 4 gives me 0 imaginary solutions. So the real solutions, I'm going to write them again. And as for the imaginary solutions, I have none. Alright, so tomorrow, please make sure that you remember to label your real solutions on here. Alright, now the next thing you have to do is find your local min. There are 2 local mins for the x values. There's actually 1 local min. So the basic local min is going to be -9, but the x value for the one on this side is -1.303. Please make sure that you round up. Now the one on the other side, because there's one on this side, that x value is 2.303. Remember, there is a reason why I'm writing these on the outside. Okay, so I'm just going to take a moment to plot those. Okay, the next thing that I'm going to need is my local max. And make sure when you're looking at your local max, you're looking in this area. So my local max winds up being 1.563. The x value was 0.5. I'm going to write that out there. There is a reason why I'm writing that. So now I'm going to plot that. And now I can just connect my dots. Notice how I'm labeling that as my local max. I'm going to label these as my local min, because that is what you will have to do tomorrow. And then I will just continue. Okay, you might also want to label these as your zeros. Okay, so you know that domain is kind of like a tug of war. Domain is how far to the left are you going and how far to the right. Well, looking at these arrows, they go in all directions forever. So my domain is going to be negative infinity to positive infinity. My range, think of limbo. How low do you go? How low do you go? Okay, so I guess maybe you guys don't play limbo, but that is what range is. How low do you go? And how high do you go? So you'll notice right here, the lowest point is -9, which happens to be our local min. So with a bracket, my range goes from -9 and then it shoots up to infinity. Continuous will always be yes because we're not doing piecewise. Now the x-intercept is always this number. Well, since I don't have a number after 6x, my y-intercept will be 0. Now my end behavior always starts the same. As x goes to the left, so this is going to the left, where does the graph end up? Well, the arrows on the left-hand side are at infinity, so that means that f of x must go to infinity. As x goes to the right, so we're going to the right, and end behavior pretty much means what happens at the end. Okay? So as I go to the right, this arrow is shooting up to infinity as well. So both of the end behaviors are infinity because we wind up going up. This end behavior is left. This one is right. Alright, absolute min and max mean absolutely how low and how high do you go. So you'll notice that looking at my range, the lowest point here is still -9. It's the same as my local min. So my absolute min and my local min are going to be the same, just for this example. It doesn't always work out that way. Now, my absolute max has to do with these numbers. Well, these numbers are infinity. I cannot measure this with a ruler. I can't. No matter if I try, it's impossible. So because I can't measure that with a ruler, my absolute max is none. Okay, you cannot measure infinity with a ruler. Alright, so now here are where these special numbers come in. They are used for my intervals. So remember, you're going to write your intervals in order from smallest to biggest. My smallest number is -1.303. My next smallest is 0.5, and my largest number is 2.303. I'm going to surround those with negative infinity and infinity. So now I'm going to make pairs. My first pair is from negative infinity to 1.303. Well, 1.303 is right there. So between these 2 points, what is the graph doing? So we have to think about a roller coaster. I start my roller coaster here, and I wind up going down the roller coaster. So this is a decreasing interval. Then I have to go to this point here. So from this point to this point, my roller coaster turns and goes up. That's an increasing interval. Then, from this point to this point, the graph goes down like a roller coaster goes down. So these 2 points are decreasing. And now the last one is from this point all the way to infinity. It looks like the graph is like going up like a roller coaster, so that's increasing. So I wind up having a decreasing interval, an increasing interval, a decreasing interval, and an increasing. So increasing interval, the first one are these two numbers. My next increasing interval are these two numbers. My first decreasing interval are those two. And my second decreasing interval are these two. You should notice a pattern. Negative infinity to this, then this to this. This to this, then this to that. Alright, so we've pretty much answered everything. The last thing we need to do is a product of linear factors. So I'm going to write the opposite of each of these factors. So the first opposite would be x plus 2. Always start off with y equals. Then I have x plus 0. Well, x plus 0 is really x. So that x is always going to be my leading variable. Okay, the opposite of 1 is negative 1. Putting an x in front, this would be x minus 1. And the opposite of 3 is negative 3. Putting an x in front, making that x minus 3. So as you can see, a lot of different factors just to answer one question. But imagine this was a multiple choice. You would have to do all of this work to figure out all of the choices. Alright, next one is number 2. Number 2 is a cubic, so I'm going to put that in my calculator. And when I look at the cubic, I notice that it only hits the x-axis at one point. That one point that it hits it is at... Uh-oh. Alright, it actually hits it at x equals 3. So what I'm going to do is put a 3 here. That is my 0. That answer is going to go down here. It will also go here for my x-intercept. Alright, since this is a degree of 3, I should have 3 solutions. I only wind up having one real because it only crosses the x-axis once, which means 3 minus 1 is 2. 2 imaginary solutions, which we will solve for later. Alright, so now let's find my local minimum, which is where the graph dips. And it dips somewhere around here. So the local minimum is at negative 5.089. The x value for that is at 1.816. I keep that on the side for my intervals. Now I'm going to find my local max. The local max is somewhere around here. The local maximum is negative 2.911. The x value is 0.184. Even though you see 183, I rounded up. Alright, so let me just take a moment to graph those. And notice how I label that as local min. And I'm going to label that as my local max. Alright, because if you label, it allows for you to answer these questions better. Alright, remember your domain is how far to the left and how far to the right. You'll notice that as I travel along this, it goes all the way left, and it also goes all the way right. So that means it's going from negative infinity to positive infinity. The range is how low do you go to how high do you go. So if you notice on this side, it goes all the way down, and then it goes all the way up. So that means that the range is also going to be negative infinity to infinity. For cubics, they're always the same. Remember that. Alright, it is continuous. The y-intercept is going to be this answer. It's always the last number. The end behavior are your arrows. The arrow on the left-hand side, so this is the left. The arrow on the left-hand side is going down to negative infinity. The arrow on the right-hand side is going up to infinity. So that's my end behavior. That's what happens on the end. As x goes left, f of x goes down to negative infinity. As x goes right, so that means right, f of x is going to go to positive infinity because it goes up. Alright, absolute max and min has to do pretty much with your range. Okay, so if you look at your range, you'll get your answers. So looking at the range, you see that my absolute minimum goes down to negative infinity. Negative infinity cannot be measured, so it's none. Absolute max has to do with this value because that's the highest point. Well, the highest point is infinity. That can't be measured, so that's none. Please, whatever you do, if you put infinity here, I'm going to mark you wrong. Make sure that you put none if infinity becomes your answer. Alright, so now we're going to take our x values and write them out from smallest to biggest. So the smallest one here is 0.184. Then comes 1.816 and then infinity. And now I'm going to make my pairs. So the first pair goes from negative infinity to 0.184. So that's from here to about here. So between these points, it looks like if this was my roller coaster, the graph is going up. So that's an increasing interval. Now from 0.184 to 1.816, it looks like if this was my roller coaster that it came down. So that's a decreasing interval. And now the last one, from here all the way to infinity, if this is my roller coaster, I'm going up. So that's an increasing interval between these two numbers. Alright, so now let's write out my increasing interval. From negative infinity to 0.184 and 1.816 to infinity. My decreasing interval are those two, and that goes from 0.184 to 1.816. Notice that they alternate. Alright, well, if I have two imaginary solutions, I need to find them. So the first thing that you should do is synthetic division. So we're going to use our real solution for synthetic division. Our real solution was 3. So I'm going to use that. The numbers on the inside I'm going to use are these coefficients. So I have 1, negative 3, 1, negative 3. And then I start. Bring down the 1. 1 times 3 is 3. Add them, I get 0. 0 times 3 is 0. Add them together, I get 1. 1 times 3 is 3. Add them together, and just like I want, I get a remainder of 0. So if I work backwards, this is my constant, this is x, and this is x squared. So put it all together, you get x squared plus 1. Now I'm going to do the shortcut because there's a 0 in the middle. So I can just set this equal to 0 and solve for x. First subtract 1. X squared equals negative 1. The only way to get rid of a square is to do the square root. Whenever you take your own square root, make sure that you put a plus minus on the outside, because when you take a square root, you really can have two answers. So now I'm going to separate this. That negative goes on the outside, that's my I. The other one is the square root of 1, which is 1. So I'm going to wind up having two answers, plus or minus 1i. Now, of course, that can be written here as plus or minus I, or you can write it as I and negative I. Now, when it says write as a product of linear factors, you always start with y equals. We'll go to our real solution. The opposite of 3 is negative 3 with an x. The opposite of I is negative I with an x. And the opposite of negative I is positive I with an x. There are my factors. All right. Okay, we did this one in class, so we have a degree of 4. Total number of solutions should be 4. So you put it into your calculator just to see how many times does it cross the x-axis. You'll notice when you put it in your calculator, it crosses the x-axis in 2 spots. At negative 4, and it crosses it at 5. That means we have 2 real solutions. 4 minus 2 is 2, meaning we have 2 imaginary. Now we're going to do synthetic division using those 2 numbers. So it'll be negative 4, and the coefficients are 1, negative 1, negative 16, negative 4, negative 80. Bring down the 1, and then just keep working it out. So you see I got a remainder of 0, which is exactly what I wanted. So now we do it again using these 4 numbers, and now using the 5. Okay, if you get 0 as your remainder, that's cool. So now if we write this looking backwards, constant x squared, the equation is x squared plus 4. We can set that equal to 0 and just solve for x. Notice that I'm going to have a negative under my square root. So I have I for that negative and square root of 4, which is 2. So my answer for x is plus or minus 2i. Which means it can be negative 2i and 2i. Because I'm supposed to have 2 imaginary solutions. Alright, number 4 has a degree of 4. There are a total of 4 zeros. So now we need to see actually how many zeros are we going to have. So if you look at your graph, it curves around negative 3. Remember, when a graph curves around like this, it's really hitting that spot twice. It's coming down and hitting it, and then it's going up after it hits it again. So you need to write that twice. So I'm going to write negative 3 twice. So that means I have 2 real zeros, meaning that I must have 2 imaginary zeros. So I'm going to do synthetic division twice using negative 3 both times. Okay, my coefficients are 1, 6, 34, 150, and 225. So now just work it out. So I got 0, which is exactly what I wanted. So I do it again. Got 0 again, and look, I have a 0 in the middle again, so I can do the shortcut. Remember, you can only do the shortcut when there's a 0 in the middle. Remember, when you take your own square root, you must put a plus minus on the outside. So x equals, i's for the negative, square root of 25 is 5, so it's plus or minus 5i. So that's negative 5i and positive 5i. That's what plus minus means. One's positive, one's negative. Okay, so you know every time you get real zeros and then you have to find imaginary, always do synthetic division first and then do quadratic formula or the shortcut. Alright, number 5 has a negative, but that doesn't really change how you're going to do it. All it says here is real roots and imaginary roots, so you still have to do everything the same. It's kind of hard for me to see this. It looks like a 3, so I will put in a 3. Okay, it winds up hitting the x-axis in one spot, and that one spot is going to be at 3. So our real roots, notice that this whole section doesn't say number of, so our real roots is only 3. Okay, it doesn't mean we have 3 real roots, it means that this is the actual answer, where it crosses the x-axis. So now we're going to do synthetic division with 3, so that we can solve for the missing imaginary roots. So if you look here, working backwards, constant x squared, the equation is negative x squared minus 4x minus 5. Notice that there's no 0 in the middle, so I cannot do the shortcut. So I'm going to do the quadratic formula using this as A, this is B, and this is C. So here it is. X equals negative B plus or minus square root B squared minus 4AC all over 2A. So there's your quadratic formula. So X equals negative B, which is 4, plus or minus square root B squared minus 4AC. That's negative 1 and negative 5 all over 2 times negative 1. Okay, so we're going to continue here. So in your calculator, make sure you put that negative 4 in parentheses, because if you don't, you're going to get a different answer. And you wind up getting negative 4 under the parentheses. So we all know that negative 4 can split into 2 factors, I and the square root of 4, which is 2. So this is equal to 2i. So when you write it again, it's 4 plus or minus 2i over negative 2. Now you know that you can reduce this because both of these can be divided by negative 2. So 4 divided by negative 2 is negative 2, and 2 divided by negative 2 is just negative 1. Okay, so your answer to this question would be negative 2 plus or minus negative 1i. Or if you simplify it one more step, you have negative 2 plus or minus I. And that's because I carried over, like I distributed this minus and minus, it became a plus. And I distributed this plus and minus and became a minus. So that's where that came from. Alright, aside from number 10, this is probably like one of the last long problems. for here, number 6, you guys are all really good with this. Just do the opposite. X minus 1. X, that becomes a plus 3. And that becomes a x minus 4. Okay, multiplicity means repeat number. So that means that you're going to repeat negative 5 twice. So when you write it, opposite of 5 is negative 5. Opposite of negative 5 is positive 5. And because we wrote this twice, we can actually just write it as x plus 5 squared. Okay, so with multiplicity of 3, we're going to repeat the 3. So that would be x minus 3. X minus 3, because remember it's always opposite with x in front. X minus 3. Since there's 3 of them, you can just write x minus 3 cubed. Alright, the last one would be x minus 0, x minus 2, x opposite of 2 is plus, so that's x plus 2, and then x minus 6. Remember what I told you about 0? That's just x. And x should always lead everything. Alright, so there are your 4 answers. Alright, number 10, you had to do your finite differences. So when you do your finite differences, always go from right to left. Because if you go from left to right, you're going to wind up getting different answers than everybody else. So go from left to right. Okay, then you have to do it again. And of course, you have to do it one last time. And because we had to do this 1, 2, 3 times, this has to be a degree of 3. Degree of 3 is called a cubic, and that will be stat calc number 6. Okay, so once you put this in, and you go to stat calc number 6, it's going to say that a equals 1, b equals negative 2, c equals 1, and d equals negative 2. That means that your equation is y equals x cubed, because it's a cubic, minus 2x squared plus 1x, or just x, minus 2. So now once you have your equation, you're going to put it into your y equals, because you want to see how many zeros do you have and how many imaginary zeros and how many real zeros. So you do all that by putting it into the y equals. And if you look, you only have one x-intercept, and it's at 2. Okay? This is your 0, or your x-intercept. Now, you have to find your local max and min. Your local min is somewhere around here, and it's a very flat local min, so you have to be really careful when you're looking for this. It's not going to be easy. You just have to make sure you're to the left of that flatness and to the right of that flatness. So your local min is at negative 2, and the x value is at 1. Okay, then you have to find your local max, which is right around here. Also, again, very hard to see because it's so flat. So just make sure you're to the left of that high point and to the right of that high point. And you find out that your local max is at negative 1.852. The x value is at 0.333. So it looks really flat when you do it, but it's very weird to look at. Alright, so now let's start looking for our, and let's make sure that we label. This is your local min, because you will have to label on the test. And this is your local max. Alright, so now you have to actually identify what the absolute min and max are, but first let's do our domain. Domain is going left to right. You see that it goes all the way left, all the way right, so that's our domain. Range does the same thing. It goes all the way down and all the way up. So range is the same. And remember I told you for cubics, they will be the same. Continuous. The x-intercept was only at 2. The y-intercept is always the last number. Now this graph is going up. Well, actually it's going down as you go to the left, so this is left. On the left-hand side, it's going down to negative infinity. And on the right-hand side, it's going up to infinity. Alright, now looking at the max and min, remember I told you that absolute max and min have to do with the range. So since the lowest number in the range is negative infinity, I do not have an absolute min. Since the highest number in my range is infinity, I do not have an absolute max. Alright, now I'm going to write my 4 x values from left to right in order. And then I'm going to make my pairs. My first pair goes from negative infinity to 0.333. If this is the seat on the roller coaster, I'm increasing. So that's an increasing interval. Now from 0.333 to 1, very small decrease. And then from 1 all the way to infinity, it increases again. Alright, so my increasing interval goes from negative infinity to 0.333, and then from 1 to infinity. My decreasing interval goes from 0.333 to 1. Remember, these x values are what you use for intervals. That's why you should always write them on the side. Alright, almost done. The last few questions are your favorite types, which are finite differences. Remember, always go from right to left when you're subtracting, or else it's going to mess up your answers. So as you can see, we do not get the same answers here, so we do it again. Again, we don't get the same answers, so we do it one more time. Alright, one last time. Phew. That took a while. So that was 1, 2, 3, 4 tries. So 4 is what we call quartic. Quart. Think of core sounds like 4. So that's a degree of 4. And that will be stat calc number 7. So you would put all of the numbers into your calculator and make sure that you go to stat calc number 7 when you're done. So you wind up getting y equals 1x to the 4th, which is x to the 4th, minus 2x to the 3rd, minus 5x squared, notice we go down in order, plus 6x, And then the last one said 9.231 e to the negative 12. Remember I told you that that's like the calculator putting 11 zeros and then putting the 9231 at the end. Well, if I'm telling you to round to 3 decimal places, when you round to 3 decimal places, this rounds to 0. So every time you see one of these, just round it to 0. So this would really be plus 0 at the end, but we really don't need the plus 0. So this is how we will end our equation for this question. Alright, two more. We're almost done. Alright, here I'm going to do my finite differences again. Alright, notice how we counted. 1, 2, 3. 3 is called a cubic. So cubics have a degree of 3. And that means that you're going to go to Stat Calc number 6 in your calculator. And when you do that, they give you nice numbers, but they're all ones. So it's 1x to the third minus 1x squared minus 1x plus 1. Alright, last question. Alright, well, we had to wind up doing this 2 times. 2 is called a quadratic. Notice it looks different than quartic. Remember, quar sounds like 4. So quadratic is 2. This has a degree of 2. And this is when you would go to Stat Calc number 5. This was your whole entire test for Unit 3B. Okay, so now you just put that in your calculator. Make sure you change the numbers from before, because the tables might change, so you don't want to have the same x values you had before. So this one gives you 1x squared. And then you have the 1.3 e to the negative 12. Remember what I told you. Take that and round it to 0. So we don't have a middle value. And then the last one was negative 100. So your answer is x squared minus 100. Alright, well that concludes the review. So all I'm going to do is write your secret message on the board, and you need to write the secret message at the top of your paper. If you write the secret message, you will get a special prize. Also, if you watch the second video, there will be another secret message which will allow for you to get another surprise. Alright, so here is the secret message for this video. All I want for Christmas, Hanukkah. So if you don't know how to spell Hanukkah, I don't know if I spelled it right, but so all I want for Christmas or Hanukkah is an A on this test. This is a long secret message, so make sure that you do fill it out. If you can't spell Hanukkah, that's fine. If you can't spell Christmas, that's fine. But you should be able to spell everything else right and get it correctly. Alright guys, good luck, and I'm looking forward to seeing a lot of good grades on this test. Remember, we are working for pizza or donut.